In a way, nuclear energy has been serving man as long as he has existed. It has served all of life. It has flooded the earth for billions of years. The sun, you see, is a vast nuclear engine, and the warmth and light that the sun radiates is the product of nuclear energy. In order for man to learn to produce and control nuclear energy himself, however, something that did not take place until this century, 3 lines of investigation, atoms, electricity, and energy, had to develop and meet. We will begin with atoms. Atomic weights. As long ago as ancient Greek times, there were men who suspected that all matter consisted of tiny particles which were far too small to see. Under ordinary circumstances, they could not be divided into anything smaller, and they were called atoms, from a Greek word meaning indivisible. It was not until 1808, however, that this atomic theory was really put on a firm foundation. In that year, the English chemist John Dalton, 1766 to 1844, published a book in which he discussed atoms in detail. Every element, he suggested, was made up of its own type of atoms. The atoms of one element were different from the atoms of every other element. The chief difference between the various atoms lay in their mass or weight. Dalton was the first to try to determine what these masses might be. He could not work out the actual masses in ounces or grams, for atoms were far too tiny to weigh with any of his instruments. He could, however, determine their relative weights, that is, how much more massive one kind of atom might be than another. For instance, he found that a quantity of hydrogen gas invariably combined with 8 times its own mass of oxygen gas to form water. He guessed that water consisted of combinations of 1 atom of hydrogen and 1 atom of oxygen. A combination of atoms is called a molecule, from a Greek word meaning a small mass, and so hydrogen and oxygen atoms can be said to combine to form a water molecule. To account for the difference in the masses of the combining gases, Dalton decided that the oxygen atom was 8 times as massive as the hydrogen atom. If he set the mass of the hydrogen atom at 1, just for convenience, then the mass of the oxygen atom ought to be set at 8. These comparative or relative numbers were said to be atomic weights, so that what Dalton was suggesting was that the atomic weight of hydrogen was 1 and the atomic weight of oxygen was 8. It is still a fact that a quantity of hydrogen combines with 8 times its mass of oxygen, so the single oxygen atom must be 8 times as massive as 2 hydrogen atoms taken together. The oxygen atom must therefore be 16 times as massive as a single hydrogen atom. If the atomic weight of hydrogen is 1, then the atomic weight of oxygen is 16. At first, it seemed that the atomic weights of the various elements were whole numbers, and that hydrogen was the lightest one. It made particular sense, then, to consider the atomic weight of hydrogen as 1, because that made all the other atomic weights as small as possible and therefore easy to handle.